to my channel Hari's Videos. Please subscribe, like and give a comment. Don't forget it. Thank you so much for subscribers. Thank you for my subscribers and thank you for my viewers who are watching my videos regularly, and request you all. So please share my channel, subscribe my channel if you not subscribed, and inform and share the channel with your friends and relatives who are studying class 10 in various schools. Right? So let's start the next topic, magnetic flux and magnetic flux density. Okay. Magnetic flux and magnetic flux density. So this topic is not be given in your new textbook, but it's one of the very important concepts. That's why I am telling you. Before that, let us discuss a few things about magnetic field of Earth. Magnetic field of Earth. As we know very well, Earth is a big magnet. Earth is a big magnet. So when we suspend any object, when we suspend any object, so it always shows north and south direction. The Earth itself behaves as a magnet. The shape of the Earth, its magnetic field resembles that an imaginary bar magnet. Imaginary bar magnet. So the south pole of Earth magnets is in the geographically north. North pole of the Earth. North pole of the Earth geographically south. The south pole of the Earth geographically north. Remember that. Right? There is a magnetic south pole near the geographical north and magnetic north pole near the geographical south. The position of the Earth magnetic poles are not well defined on the globe. They are spread over the area. The axis of Earth magnet and the geographical axis do not coincide with each other. So the axis of Earth magnetic field is inclined at an angle of 15 degrees with the geographical axis. With the geographical axis. So the axis of Earth tilted 15 degree. So the Earth magnetism is due to the magnetic effect of current which is flowing in the liquid core at the center of the Earth. Thus, Earth is a huge electromagnet. So much no need. We will discuss. Maybe you already learnt in solar studies, so no thinking. But Earth is a big magnet. It acts as a big magnet because of inside the core liquid. Inside flowing in liquids core at the center of the Earth. North pole of the Earth is geographically south. South pole of the Earth geographically north. When you suspend any object, shows north and south. Keep in mind. Let us come to our topic: magnetic flux density. Magnetic flux and magnetic flux density. So remember that we understand that magnetic field. So the space surrounded by the magnet, is called as the magnetic field. So magnetic field lines are, if the magnetic field lines are very close to each other, then the magnetic field strength is more. Then already we discussed some properties. Magnetic field lines do not intersect each other. Magnetic field lines are emerge from north pole and merge into south pole. Right? So the density of the magnetic field, more magnetic field near the poles, which close, they are very close near the poles, then separated from other places. let us discuss magnetic flux and magnetic flux density. Right. Can we give certain values to magnitude of the field at every point in the magnetic field? Can we give? Already we told that magnetic field has magnitude as well as direction. So in what way we have given the magnitude? So consider a uniform magnetic field in a space. Imagine that a uniform magnetic field in the space. Imagine a plane of surface area or certain area placed perpendicular to the field at a certain point. The magnetic field as shown in the figure. See, these lines are denoted the magnetic field lines in a space. In that we are imagining a area A. In this area is perpendicular to the field lines. Perpendicular to the field lines are the magnetic field. So the imaginary plane has area A, which is perpendicular to the magnetic field. It is perpendicular to the magnetic field. Here, observe that some magnetic field lines are passing through imaginary area A. Imaginary area A. So, the number of lines means magnetic field lines passing to the plane of area A. Passing to the plane of area A, perpendicular to the field. Field nothing but magnetic field is called magnetic flux. Magnetic flux. So, how many magnetic field lines are passing through this imaginary plane area? That lines, the number of lines are nothing but magnetic flux. So, it is denoted by symbol called phi. Symbol called phi. Flux depends on the orientation of the plane in the field. So here the field is perpendicular. If it is made some angle, if it is made some other angle, if it is parallel to, then what will happen? The magnet. This means the number of lines are passing through plane area different. So, the magnetic flux depends on the orientation of the plane in the field. How the field is, means how the area or the plane area is it parallel, perpendicular, or it makes any other angle. This depends on magnetic flux depends. Depending upon the orientation of the plane area in a magnetic field. So, the magnetic flux depends. Then the SI unit is Weber. The SI unit is Weber. Then the CGS unit of magnetic field is Oersted. The magnetic CGS unit of magnetic field is Oersted. Who is Oersted? Hans Christian Oersted, who gave the relation, who gave the interlink between electric current and magnetism. The father of magnetic effect of electric current. You can say that simply. Electromagnetism. The scientist who introduced the electromagnetism. This is about magnetic flux. Then magnetic flux represent the number of lines passing through the imagined plane in field. Of course, flux depends on the orientation of the plane in the field. The SI unit Weber. Now, strength of field is easily defined as the strength of magnetic field, nothing but the magnetic flux, nothing but strength of magnetic field. The strength of magnetic field is represented with the holistic one of, right? So now the strength of field is easily defined using the idea of flux. If the imagined plane is perpendicular to the field and has a unit area, means the area has a unit area, then the flux through this plane of unit area gives the strength of the field. Strength of the field. So the strength of the field is technically called magnetic flux density. Magnetic flux density. So magnetic flux density means the strength of the magnetic field. How can we know the strength of magnetic field? So in a magnetic field, if we imagine a unit area, if we imagine a unit area, through this unit area, how many number of magnetic field lines are passed, then denotes magnetic field strength. This magnetic field strength is denoted or explained by the term magnetic flux density. Magnetic flux density. So the magnetic flux means the number of magnetic field lines. The number of magnetic field lines passing through unit area. Passing through unit area. Taken perpendicular to the field. Perpendicular to the field is called as magnetic flux density. Magnetic flux density. So magnetic flux density B is equal to magnetic flux by area. Magnetic flux by area. So magnetic flux density represented with B, magnetic flux represented with phi, area represented with A. So magnetic flux density B is equal to phi by A. From this, magnetic flux phi is equal to BA. Flux, nothing but magnetic flux phi is equal to BA. As we know, magnetic flux units Weber. Then area meter square. So unit of magnetic flux density. Unit of magnetic flux density is Weber by meter square. Weber by meter square. This Weber by meter square is called Tesla. It called Tesla. This is about magnetic flux and magnetic flux density. So as we discussed, flux depends on the orientation of the plane. Orientation of the plane. So here, this is the magnetic flux, number of magnetic field line. So here, the area is not perpendicular. The area is not perpendicular to magnetic flux. Then there is some angle. There is some angle to the flux and area. So that is taken as theta. Is taken as theta. In this case, we have to use this formula phi is equal to BA cos theta. BA cos theta. So this cos theta is taken because it is means the area is perpendicular. The area is perpendicular aithe, then we have to take cos theta. If area is, the object is parallel aithe, then we have taken sin theta. Sin value we have considered in case the object or the area is parallel. We can take sin value. If the object or the plane is perpendicular, then we can take cos value. Why you will learn in higher studies because of here no more much information is given, just given the formula. So if it is perpendicular, so now it is the perpendicular and the cos theta. If it is parallel, then we can take it as sin theta. This is about magnetic field. This is about the magnetic field. I hope you understand. So if it it is possible, read the whole 10th class textbook regarding this chapter. You have much information. Much information regarding this magnetic field, electromagnetism, how the motors works, how generator works, how Faraday's laws, Lenz laws, all are you understand. Means maybe understand difficult to understand, but you have get some idea. So that's all for today, and that's all for today's session. Thank you so much, and once again I am requesting you, if you not subscribe, please subscribe, share the channel with your friends and relatives who are studying in other schools, and ask them, share their friends, and ask them to watch the videos once. If they like, subscribe. So the most request, the very important request, humbly requesting you, give a comment and give a like. So thank you so much. Signing off. Hari PS videos. Thank you so much. Your Hari PSR. Thank you.